This lesson is the basics of exception handling. The objectives for this lesson are to learn the basics of .NET exception handling, using try-catch blocks, add a finally block to always execute code, learn the properties of the exception class, learn how to catch specific exceptions, what is exception bubbling, how to throw exceptions, and how to create your own custom exception classes. If you do not add exception handling to your code and your code happens to generate an error, well, what happens? Well, the .NET default error handler will kick in, and the exception is then raised to the .NET runtime. And at best, you'll get an error message indicating what went wrong, but at worst, your application could just simply stop with no warning. And that's not something you really want to have happen to your user. So we're going to add some error code around any code that could potentially fail. And we do that with a try and a catch block. So we have a try block, so try, curly brace, open curly brace, and then you write code, and in that code is somewhere that could potentially raise an error. Opening a connection to a database, opening a file, trying to print. And then we have the closing curly brace, and then we have a catch block. So catch, open curly brace, and then what we're going to do to handle that error or maybe display some error message to the user. So each of these are two different blocks of code that all form standard C# error code. I'm going to write some very simple code for this particular lesson that shows us what we can do when we attempt to open a file and retrieve the file length. So there's a couple of things that could happen, right? I mean, there's things that can go wrong. The file doesn't exist. The path doesn't exist. You don't have permission to access the file. The file is locked. Maybe some sort of network error if you're trying to go to a network drive. Maybe you get it open, but you can't retrieve the file length for some reason. There's so many possible exceptions that could happen here. And then if it does, let's find out what happens by the default when there is no exception handling in our C# code. Here's the code we just saw on the slide where I have a long variable called size. I have a file stream called fs. I do fs equals file.open, and then I pass in a verbatim string, so I can simply use one backslash. And I'm trying to go in after a path d:\samples test.txt. I'm trying to go after that folder and that file in that folder. And then I'm telling it that I want to open. That's the file mode. Then, if I get that open, I want to do a size equals fs.length. I want it to give me back the length, and then I would close that file stream. So it seems like pretty simple code. The problem is I know the path exists, but I don't have that file there. So when I press F5 and I try to run this, it bubbles the exception up to .NET. .NET says, well, wait a minute, I'm running under Visual Studio, so it passes that value back here to Visual Studio, which then reports the error to me as the developer. And it's telling me the exception is unhandled. I didn't put any try-catch block around this, so it's an unhandled exception. It's telling me the type of exception in bold there, system.io.file.not.found.exception, because the message it's telling me is could not find the file, d:\samples\test.txt, because I have no test.txt there. You can even come down and see additional information, so I could view all the details about this. So it's showing me a lot of different information, and I can kind of, view into some of these things and see what they look like, the message. I got a source here of where that message is coming from, the whole stack trace of how it got there. So we can see all the way down here. I was in my samples file. I was trying to do a file.open, and etc. So lots of information that I can get from Visual Studio. Let's add a simple try-catch block around any code that can fail. So if an error occurs within the try block, then code automatically jumps down to the code within the catch block. So instead of that error bubbling up to the .NET runtime and ultimately to the user, or in our case to Visual Studio, we want the code to jump down to within this catch block, and then I can write code to do whatever I want to do. So I could bring up my own error message to the user, for example. I'm going to move those 3 lines of code within the try block, And we saw that the code was having a problem with file.open because that file did not exist. So right on that line of code will jump down to the catch block, and I'm going to simply just write out error occurred. So let's take a look at doing this to our previous sample. So here's our code. I moved the 3 lines of code that could fail within the try block. Didn't necessarily need to move the variables inside of there because those are just declarations of variables. Those are not going to fail. It's just the code inside of here. When I'm trying to open a file, when I'm trying to get the length of the file, or when I'm trying to close the file, those are the lines of code that could potentially fail. And I'm going to explain a little bit later why I still think it's a good idea to declare your variables outside of the try block. But anyway, let's go ahead and try running this right now. And we'll see that we no longer get an error in Visual Studio because no error is being bubbled up. We have caught the error right where the error occurred. So we're taking control and we're saying, let's just write out that an error occurred. Very simple, easy way to handle exceptions that could potentially occur within your application. Now that code was fine, except we really didn't give the user a lot of information about what went wrong. So how can we determine what happens within that catch block? Well, what we're going to do is we're going to add an exception class within the catch block, and we'll assign it to a variable name. And that exception class provides us with very useful properties and methods. We get a message property that returns the error message that says it could not find the file. We get the stack trace, which returns the complete call stack of how you got to the error. Useful for us as developers, not very useful for an end user, however. We have an inner exception, just in case there's another exception that occurred. There can be 2 or 3, there could be multiple exceptions that occur on the same line of code, and they would all be represented within this inner exception property. So we could actually walk this list of exceptions to see if there's any other exceptions there. And then the toString, this returns kind of a lot of these other ones, the message, the stack trace, a source. It returns a lot of information about that error. Again, useful more for us, not necessarily for our end user. So to retrieve that exception, we simply declare it in the catch block. Within the catch, we do a open parenthesis exception and then give it a variable name. I call it EX. In fact, that's a pretty standard convention you'll see, and then a close parenthesis. So from that, we can then hit all of those properties I just talked about, message, inner exception, and then we can hit the toString method as well. But we use an exception object to get that error information within the catch block. Again, you can assign whatever variable name you wish to have there, though. All right, let's take a look at catching with the exception object and then displaying some of the properties in the exception object. Here you can see on line 9 where I'm catching exception and giving it to the variable name EX. So when an error occurs, that error information that we previously saw in Visual Studio, that information is given to us in the form of this object. I can then display the message, the inner exception, the source, the target site, all that information I can display on the console. Now this isn't generally something you would display to a user. In fact, you'd probably write this information to maybe a log file somewhere or into a table in a database for you to look at, and then you might have something else that you display to the user about what went wrong. So if we run this, here's all that information that gets displayed. Again, not all of this is very useful to the user, but to us as a developer, yeah, it might be nice to know that, hey, we started out within the program.cs file, and we were trying to do the file.open, and it tried to call all these other things until we finally got the error message that it couldn't find the file. So great information here in this exception object, and this is definitely the pattern you want to do. Always catch some sort of exception. Another block that you'll probably want to add is what's called the finally block. Now, the finally block is used for code that must always run, regardless of whether the code ran successfully or if there was an error and the code went through the catch block. So either way, we want this type of code to run, which would be examples of like closing files, closing connections. We probably want to always have a finally in those particular cases where we need to do some sort of cleanup on something that we were working with. Let's take a look at using the finally block. For our sample here on the file stream, a file stream is something that you should close when you're done with it. So this is an example of something that you would put into the finally block. However, you do need to be aware that when you come into the try, if the file.open fails, fs will not be anything. It will be null because we've assigned it to a null on line 2. Just make sure you're using your nullable operator to check to make sure that that exists before you try to call the close method on that variable. If you remember, I can assign a question mark to this because what I've done in the C# samples, properties, build, remember, when you create a .NET project, by default, they're going to turn this nullable to enable. So if you disable this, which I prefer to do, but you may or may not, so it depends on how you created your project and whether you came in here and disabled this. But if we go back here now, it's going to complain about this and say, well, wait a minute, you can't have a question mark on that. One way or the other, it just all depends on that nullable setting, on whether you'll be able to make it a nullable type or whether you can just assign it to null. That's a compiler option. But either way, you still want to use that nullable operator down on the variable itself when you do fs.close. What we've done so far is use the generic exception object. This is the base class for all other exceptions because there are some operations that you'll try to do that would provide different exception based on what happens. And the documentation will list which ones might occur. So for example, the file.open method that I'm using can throw argument exception, path too long exception, directory not found exception, and a whole host of other ones. In fact, you can look that up again online in the Microsoft documentation. But what's neat is we can actually use those specific exceptions to handle different errors differently. All of those specific exceptions I just talked about inherit from the exception class, which means they get all the properties and methods of the exception class, but then can add on things that might be specific for them. So C# can pick a specific exception if it can, such as drive not ready. If that doesn't match any of those specific exceptions, it might use IO exception. If none match, then it'll just resort to an exception class. If none match and you don't specify exception, well, that's when C# will just throw the exception and the next method up catches it. Or in our case, right now, if we didn't have any, it would just simply go to the .NET runtime, which then would report it to us in Visual Studio. Now, there's a lot of information there. It'll make more sense when you see the sample that I'm coming up to, but there is an exception inheritance hierarchy. So the order of the catch blocks that we're going to do matters. The runtime checks an is a relationship. So if it throws an IO exception, it's going to look in the catch block list and say, do you have an IO exception there? Is it a IO exception? And as soon as the runtime finds a match, it runs the code within that catch block and then finally exits the whole try block after that. Now, like I said, it's going to make a lot more sense right now when we go into the specific exceptions. So let's take a look. This is what I was talking about when I'm referring to multiple catch blocks and specific exceptions. So we try to open the file again, so that hasn't changed. But now look, I have a whole list of catch blocks here. I have an argument out of range exception. Now that one has to go before the argument exception because argument out of range exception inherits from argument exception, which eventually inherits from the exception object. Then on line 15, I catch a path too long exception. And then down below, I have directory not found exception, and then a file not found exception, and then an IO exception. And again, directory not found exception, file not found exception, both inherit from IO exception. So if I were to leave either one of those out, it could still match up to an IO exception. We then have unauthorized access exception, not supported exception. These are the list of all the ones that the file.open method will potentially throw. What's neat about this is you could give very specific error messages based on one of these. I'm simply printing out ex.message on all of these, but you could put in something very specific if you wanted to about, hey, that directory you're trying to access is not there. For example, under line 19 where I'm catching a directory not found. So you can be very specific on your error messages if you put in multiple catch blocks. As I mentioned, if it doesn't match up to one of these in a catch block there, then it'll hit that catch exception. That's the catch-all. If you leave that out, it'll still run the code in the finally block, but it would then throw the error up to the next higher method wherever it got called from. And if there's nothing there, that again is going to cause your application to abort. So let's try this out. I'm going to set a breakpoint here. I'm going to run this. I'm going to press F10 to make it go, and look at where it says file not found. So it went to the file not found exception because that's what the error was that got thrown. If I modify this and I put in an invalid directory, and now I run this and press F10 here, it now goes to the directory not found exception. So you can see there's all sorts of different things that could happen here. If I had nothing in here, for example, and we try to run this, press F10, we get an argument exception. It's saying, well, wait a minute, you got an empty path. That's not valid for opening a file. So it throws that particular exception. Lots of different ways that we can handle exceptions within our application. I'm not saying you need to do all of these. It's going to be up to you on how you want to handle any specific exception that gets thrown.